Welcome to Chapter 7, Part 2. So let's talk about more ways of creating precipitation. So the learning objectives for this online lecture are to understand the process of creating rain droplets, but using the ice crystal process, which includes accretion and aggregation ideas, the idea behind cloud seeding, and the cloud types that cause precipitation, what I call the key ideas behind that. All right, so let's start with the ice crystal process of rain formation, also known as the Burgon method of ice process formation. So this is extremely important in middle and high latitudes. So you have this high altitude cloud here. Let's see. Let's get my point right. So you've got a cloud in the high atmosphere about around 7,600 meters, and it's only ice here. It's minus 40 degrees Celsius, and then you got a section of the cloud between 7,600 meters and about I'm thinking somewhere around 3,000 or so-ish meters. You get the freeze line, and that kind of depends on the atmosphere where it's going to be at. But in between these regions, you get a mixture of ice and supercooled water. And what supercooled water is water that's below the freezing point or below 0 degrees Celsius, but hasn't frozen yet. It's still liquid, so we call it supercooled. It hasn't been able to find any place for it to freeze onto. And then the lower part of the atmosphere, these clouds usually have its baseline around 1,000 meters, and that has a cloud of just liquid water. And so these clouds are always called cold clouds. Okay, so let's talk more about the freezing process. So for an ice to form, it's got to have an ice nucleus, just like for a water droplet to form or a cloud droplet to form. You got to have a condensation nuclei. There's got to be something for the ice to freeze on. So we call this the ice nuclei. There is a process called homogeneous freezing, and basically this is when pure water freezes without the use of any ice nuclei. And then we can also have contact freezing, and basically that happens if supercooled water after a collision with a contact nuclei will freeze. Usually the supercooled water needs some agitation to change its phase from a liquid form into a solid form or the so-called ice crystal. Let's talk about some other processes that happen here. So at sub-freezing temperatures, the ice crystal process causes ice crystals to grow larger at the expense of surrounding water droplets. So what is this? Well, the saturation vapor pressure above a water surface is always greater than the saturation vapor pressure above an ice surface. Think about this. Ice is solid, so solids are more tightly bound to the material than a liquid, so there would be less chance for the vapor escaping from the solid. Okay, so that means less water molecules around it, which means a lower vapor pressure, and this causes a pressure difference. And I'll show what happens. So here we have two molecules. We have liquid here that's high vapor pressure. This is high. And over here we have our ice, and that's at low vapor pressure. And all vapor pressure goes from high to low. I should say all pressure goes from high to low. So these, the pressure around here is higher, so these water molecules are going to move towards the ice. If they collide with it, they will stick and freeze, and then the ice crystal will grow larger. So this is what is meant by the ice grows larger at the expense of water droplets. All right, so other formation process, one is called accretion, okay? And this is the process of water freezing on the surface of an ice crystal. This causes the ice crystal to grow in size, and this produces a type of precipitation called grapple or rime, usually small balls of ice that form. And the other one is aggregation. So this process is caused by ice crystals colliding, and they shatter, and then these shattered pieces come in contact and then freeze into a larger crystal, and this creates snowflakes. So I'll show you the process. So here is the accretion process. I've got a solid form of ice here, and it's falling. You see how it's swept out a column of air right here that has removed all the cloud droplets, and those cloud droplets have been frozen onto this ice, and that's accretion. Now here's the aggregation process. We've had several snowflakes collide and they break apart, and then these small parts will come back together, and this causes what we call a snowflake. Now, the shape of the snowflake depends on the temperature of the air at the time that they come back together, and then there's a whole different way of classifying them, but I'm not that concerned that you understand what type of snowflake is going to be formed at which temperature. I want you to understand the processes of creating larger ice particles as they fall through a cold cloud, namely the accretion process and the aggregation process. All right, so in order for ice crystals to become large enough to create precipitation, the ratio of ice crystals to water droplets must be greater than or equal to 1 in 100,000 or 1 in a million. That's 1 ice crystal for 100,000 cloud droplets, or 1 ice crystal for 1,000,000 cloud droplets. Okay, so, and if these process conditions, if these conditions exist in the cloud, we can get some precipitation to fall. All right, so let's talk about how we can induce precipitation. There's a process called cloud seeding. To increase the number of cloud particles, to increase the number of smaller particles in the atmosphere, we call them condensation nuclei, or ice nuclei. That's what cloud seeding is we try to put these small nuclei in the atmosphere so more ice crystals will form, or more water droplets will form, and hopefully this water droplets will fall out of the atmosphere and give us rain. Last I heard, these methods were not proven to happen in a reliable rate. All right. So do we know anything that we can put in the atmosphere that might enhance the ability for the water or ice crystals to form? And we talked about them. I mean, salt's a good one. Acid rain, but I don't think we want to do an acid rain. I believe they use some silver nitrate. Might work also, but it just depends on what you have available. All right, so there are 2 types of clouds that produce precipitation. One is the nimbostratus cloud, and that's a low liquid water cloud, and the other one is the cumulonimbus cloud, which is a high liquid water cloud. They both start with ice crystals, except in the low liquid water cloud you get more aggregation. The ice crystals will fall, absorb have more collisions. The particles of ice will aggregate back into snowflakes, and if the cloud is cold enough, you'll get snow at the bottom, but if it's warmer, the snowflakes will melt and turn to rain. And then you have the high liquid water clouds. You get more riming here, or rimer crystals, so the water droplets will freeze by themselves, and then more water come into more contact, and you get bigger ice crystals, and you can also get what they're called ice rings. You can definitely see the difference in the different types of water that is creating the ice. And then you get what is called grapple, which are basically the ice petals. If it's cold enough, you can get hail. If it's warmer, then these grapple can melt and you get rain. And those are the 2 types of clouds that can produce precipitation using ice crystals. So the key ideas to remember are nimbostratus is a low liquid water cloud. A cumulonimbus is a high liquid water cloud. There are some altostratus clouds that can also be associated with precipitation. And most warm layer clouds are not generally associated with precipitation. So I hope you have a better understanding of the processes of creating rain droplets using the ice crystal process, how accretion occurs, and how aggregation occurs, what is cloud seeding, and the types of clouds that can cause precipitation. Basically, you've got the nimbostratus cloud and the cumulonimbus cloud. All right, this ends chapter 7. See you in class.